All right, you need to be in your notebook on the page that says Marble Ramp Data. And on that, there's going to be two charts. And what we're trying to do is find some relationships here. You need to look through my PowerPoint, my lessons PowerPoint, to also see what other notes we took on this. But basically, if you look at the top chart, that's what we're going to start with. We're going to work on height of the marble. And we're going to make this ramp and talk about how there is potential and kinetic energy throughout this ramp and how it transfers to each other. So in the first chart, we focused on ramp, on the ramp. So if you look at the ramp that we made, you can kind of see we used a ruler. So here's our ramp that's up. And then down at the bottom, we have like what I call the chute, and we have a cube there and another ruler so we can measure. So we talked about it. We said, well, we could put a marble on this ramp, and as it is going down the ramp, it's going to, I'll show that again. I don't think I did a very good job. As the marble goes down the ramp, it's going to push that cube. So we said, well, where's the potential energy? Potential energy's position? Well, wherever I place further up or lower down on the ramp is where the potential energy either is higher or lower. So if I'm way up here, I have high potential energy because I'm way off the ground. Gravity's going to pull me faster, accelerate. And then, but if I'm down here, I have less potential energy because closer to the ground, gravity is going to have less acceleration. So then we said, well, how can we measure the kinetic energy after we let it go? So that's when we talked about this cube here. Kinetic energy is going to be transferred into this cube, and we're going to measure how far that cube moves. So top chart, we're going to start at 5 centimeters, run 3 trials, do an average. 10 centimeters, run 3 trials, do an average. 15, 20, 25, and then see if we can find this relationship. So we're going to show you one here, and you can fill in the chart. I'm going to start at 5 centimeters, which is down here. I'm going to let it go. And then we are going to measure the front of the cube there, which, if you can tell, it's about 6 centimeters. I don't know if you can tell on the camera or not, but the 6 is right here. And that's about the front of the cube. So on our chart, trial 1, we would do 6. Okay? And then I'm just going to do, for the sake of this video to make it quicker, we're just going to assume it's 6 every time so that we can have an average of 6. Normally you would do it 3 times. Now I'm going to show you a 10. And if you want to get real data, you can ask a group member. This is just me trying to make it quicker for video. So I'm going to go up to 10. Okay. Let it go. And looking at it, the front, we're at about 9. So for 10, it's about 9. So for all 3 trials. And my average, I'm going to put 9. So I got about 6, 9. Now I'm going to go up to 15 on the ramp. So I'm going to pull this back a little bit. I'm going to be up at 15. Let it go. And now I'm up to about 12 and a half. You see I'm at about 12 and a half. So we'll just make that . Okay, so on 15, I just put 12 and a half all across the board. Now I'm going to go up to 20. Put my cube back every single time. Wow, so if I look over here, my cube moved about 19. So on my chart again, under 20, I got 19 across the board. Just again, because I don't want to do it so many times. And now I'm going to go all the way up to 25. So what do you think is going to happen here? We're going to go way up here. 25 is way up here. And let it go. And if you look down here, the cube is about 21. So 21. All right, so if you look at this chart, where did we show potential energy? So if hopefully you figured out we did it right here. So we're going to label this column potential energy, because that's where we measured it. That's what we changed. And then we were trying to see the relationship of kinetic energy. So where is the kinetic energy shown? Well, we did 3 trials, and the final one would be our average. So that's our kinetic energy. Okay, so if you looked between potential and kinetic energy, what's the relationship? So as potential energy increased from 5 to 25, what happens to our numbers here? 6, 9, 12, 19, 21. They also increased. So what I told the kids to write here is, if PE, we're just going to call it PE, goes up, KE goes up, and vice versa. If it goes down, the other one goes down. So what is that called? That is called a direct relationship. Okay? One goes up, the other one goes up. One goes down, the other one goes down. That's the relationship between potential and kinetic energy. So then at the bottom, they changed a little bit, and this one gets a little bit harder to do. But again, we have, we're going to do something different. We're going to release now at 10 centimeters every single time, but now we're going to see if we do 1 marbles versus 2 versus 3 versus 4, 40 versus 5. We're going to change the number of marbles each time. So let's start with 1 marble and do 5, which we've already done this. We did it all the way at the top, so we should get something similar. That was the first thing we did up top. We're just going to do it again. So 5 again, drop it, 1 cube. And this time we got about 6.5. Remember, you're not going to get the same every single time. So again, just for simplicity, 6.5 with an average of 6.5. Okay, now I'm going to go up to 2 marbles. So let's put our cube back. We're still going to release at 10 because we want to control our ramp height. Okay, here's 10. 2 marbles and go. And if you look, it's about 19. So you can already see that the kinetic energy is huge, a lot more than what we did before. Up top, the numbers were 6 and 9 for 5 to 10. Here, when we double our marbles, we went from 6 to 19. That's a huge difference. So just keep that in mind. We'll learn more about that later. Okay, now we're going to go up to 3 marbles. Still releasing at 10. Well, shoot, sorry guys. I lost my ramp. Let me get my ramp. Okay, so let me put my ramp back here. What I told people to do, and you're not going to be able to see all of this move, but I'm going to put my camera here so you can see at least most of it. You can see me release out. I usually tell them to put their finger at 10, load up the 3 marbles, and let it go. Well, this one went, you can't even see it. It went almost all the way off. So at the end, it was at about, look at the cube, it's about 29 and a half. So now we've gone up to 29 and a half when we get up to 3 marbles. Okay? Same numbers all the way across. Now when we go up to 4, we're probably going to go off the charts here, right? Because it seems like it's increasing quite a bit. We actually go off the charts. So I'm going to put 4, reset this. Okay. It's going to go far here. I'm going to put my finger at 10, load up 4 marbles. Okay. And release. So that one is not going to work perfectly because our ramp is not long enough. But we're going to go ahead. We know that the ramp is about 29 and a half to 30 centimeters. Let's say it's 30. So I need to add on another, looks like I need to add on another 10 and a half. So that would be 40. So that's about 40. Okay, so on my chart, I added 40. And again, with our light ramp not being long enough, that causes a problem. But that's okay. We know that's 30, so maybe we need to go ahead and put this here so it won't go anywhere. All right, now we're going to load up 5 marbles. Okay, so I'm going to put my finger at 10. Finger at 10, load up 5 marbles. Oh no! That's hard to get them working. And make sure our disc is out here. Don't want that in the way. And go. And if you notice, the marbles kind of bounced it, so it really didn't go as far as it normally would if it had been on a normal shoot. So this one went about, let's see, another 14. So that would be about 44. Normally it would have gone a lot further, but since our ramp is not long enough, that we have some error there. All right, so now on our chart, as we increase number of marbles, okay, what do you see? These numbers increase, number of marbles. You can see these increasing a lot, especially from 1, 2, and 3, and even 4. Once you get to 5 and it starts getting off the charts, it gets a little harder. Well, the number of marbles we were trying to represent as a mass. If you increase the number of marbles, you're increasing your mass. Okay? And this, again, is kinetic energy. So label it. Okay? Now, what do you see is the relationship? So if mass increases, KE increases. And vice versa. If mass decreases, KE decreases. This is, again, a direct relationship. We're going to get into it more mathematically later, okay? But as you can see, just remember, mass goes up, kinetic energy goes up. If PE goes up, KE goes up, and vice versa. This is a direct relationship. But you can tell already the numbers are very different. All right, now you need to turn the page and do page 37, answering the questions. Okay, I want you to pause the video and try them. Okay, I'm going to assume that you have paused the video. I'm going to try to go over these with you. But how does the marble gain potential energy? Well, look at our ramp. How did we get it to gain potential energy? Potential energy, remember, is the position on the ramp. So number 1, if you go up the ramp, you're gaining potential energy. Okay. Number 2, what happens to the kinetic energy indicator, the distance the cube travels, as the potential energy, marble height, increases? Well, if you look back at our chart, for number 2, as potential energy increased, KE, kinetic energy increased. That's number 2. And number 3, how is the potential energy related to kinetic energy? That's, again, just your normal. One goes up, the other one goes up. Okay. So number 2, the kinetic energy increased. And number 3, the relationship is a direct relationship. When one goes up, the other one goes up. When the other one goes down, the other one goes down. Okay, number 4. Where does the kinetic energy from the marble come from? Why doesn't it just stay up here when I let go? What's making it go down? Okay, as most of you realize, that number 4, that should be gravity is what's giving it its energy. Okay, that force. How does the mass affect kinetic energy in a collision? That's called, a collision is when the collision happens here. The word collision means when 2 cars collide, the marble hitting the cube. That's a collision. So how does the mass of the marble affect that collision? We'll go back and look at your charts. The mass increased, the kinetic energy increased. That's it. That's all it's asking for you. Again, it's another direct relationship. Later on, we're going to get into the numbers. You can see that these numbers increased a lot more than the numbers up top. So that's important. It's not just you double the ramp position, you get the average kinetic energy. When you're talking about mass, you double the number of marbles, you're going to see your kinetic energy is going to even be more than doubled. You can see that already. Doubling 6.5 should have been 14. We got more than that. We got 19. Whereas if you look up top, 6 and 9, you should have gotten 12. 6 times 2 is 12. So we're a lot closer there. We're a lot lower. So something's a little bit off, but we will work on that later.